Welcome to this tutorial. I'm going to explain on Kcse 2020 Maths Paper 1, question number 13. The question read, a chord of a circle 7 cm long subtends an angle of 60 degrees at the center of a circle. Determine the area, correct two decimal places of the major segment of the circle. There is two things that a student needed to understand here about the difference between a segment and a sector. So if you realize you draw a circle here, if this is the center of the circle, and then you have an angle subtended at the center by this chord, the chord that I'm talking about here, we have a chord here, and then this part that I've extracted here, we call it a sector. In the sector here, we have this part is called a segment, and this is the minor segment. Therefore, the remaining part is the larger segment. The whole of this remaining part is the larger segment. So after understanding that, then we need to go back to what we learned. The formula I gave you, you can either use that one of finding you can find the area of the larger segment. If we have the center here, or this is the chord is here, the angle here is 60 degrees. So we are given this as 7 centimeters, and therefore we are after finding the radius here. I gave you a formula from my previous tutorial that to find the length of a chord equals to 2r sine theta over 2. So if I use this formula, I can easily say that 7, which is the length of the chord, 7 equals to 2r sine of 60 over 2. So 7 equals to 2r sine of 30. So you realize that 7 will be equal to 2r times sine of that is a half, and the 2 cancels, so that means r equals to 7 centimeters. So we already know the radius here is 7 centimeters. 7 centimeters is our radius. So if we know the radius is 7 centimeters, we are after finding the area of this larger segment. So to find the area of this larger segment, we can easily find the area here, that is this sector, the area of this remaining part of the sector, that is the larger sector, which will be the angle that it will subtend is now 360 minus 60, it will subtend an angle of 300 degrees. So we shall have, we know the area of a sector, that is area of a sector equals to theta power over 360 pi r squared. So the major sector here now it is 360 minus 60, which is 300 degrees. So we shall have 300 degrees over 360 times 22 over 7 times 7 squared. So here we shall have 30 over 36. That is 6 here is 5 times. 6 here is 6. So 5 over 6. This is 49. Here is 7 times. So you calculate and get your area to be equal to 128.383 centimeters square. So if you calculate that, you get 128.33 centimeters square, and therefore, after finding the area of the larger sector, we also find the area of this triangle, because the area of this triangle it will be part of the segment, of the larger segment. So area of triangle will be equal to half AB sine of theta, because we have A and B and an included angle. So we shall have half times 7 times 7 times sine 60 degrees. So here we shall have, you just use your calculator, 216 centimeters square. So if you find this area, that is of the triangle, if we add the area of this larger sector, we shall get the area of the larger segment. The area of the segment now becomes area segment will be equal to, this is 128.33 centimeters cubed plus 21.216 centimeters cubed. Remember, you must answer as per the question. The question was correct to 2 decimal places. So you add the 2, 128.333 plus 21.216. You add, you get 9. You get, this is 4, you get this is 5 point, this is 9, this is 4, you get this 149 point. 1 decimal place, if you move 1 decimal place, this will not change this, so it remains the area as 149.5 centimeters square. This is to 1 decimal place. So that is what you were supposed to do. There is another way you could have done it. If you want to bisect here, so that you get, because this now becomes a isosceles triangle, so that you find 30 degrees here, and you have this 3.5, you use the SOHCAHTOA to find the radius. So that was one way of doing it, or you want to go the route that I've used. Thank you for listening to my tutorial.